Hello, welcome to Datadog 101. My name is Matt Williams, and I'm one of the evangelists here at Datadog. Datadog 101 is a series of videos that will show you everything you need to know about the platform. In this video, we're going to talk about aggregation. How do we take metric values from thousands of sources for a given time span and display them on a graph that may be 300 to 500 pixels wide as quickly and efficiently as possible? When you look at a graph on one of our dashboards, you may wonder why the graph gets smoother as you zoom out. You may also wonder why locally collected metrics from tools like htop don't appear to agree with what might display in our graphs. It all has to do with aggregation. Let's say we're collecting a particular metric on 10 different hosts, and we're displaying that on a graph with a one-day time window. Assuming metrics are collected every 15 seconds, that's about 5,760 metric values per host that need to be shown in that same one-day window. Assuming the graph is 500 pixels wide, and that we need some space between each point so that we can distinguish them, we can only show a maximum of 200 to 300 points from left to right. And depending on how I want to display the data for all 10 hosts, I may want to view a single line or have them grouped by some other tag. Therefore, we have to aggregate the data in multiple dimensions. For this example, we have a graph showing one day of data. Ideally, we want to have about 200 to 300 points showing, and it's easier for us as humans to grasp if the bins of data are nice round numbers. There are about 5,760 points in the day for one machine. If we divide that by 4 to see 1-minute intervals, we get 1,440 points. That's still too many to fit on the graph. A 2-minute interval gets us to 770. That's closer, but still too many. By going down to 5 minutes or 20 of those 15-second intervals, we have about 288, and that's perfect. So we have 20 metric values that we need to aggregate down to a single value to display on the graph. The first point on the graph is labeled 12 o'clock and represents the data from 12 o'clock to 12:04 and 59 seconds. To achieve this, we take an average of all 20 values and display the result. When you zoom out further to show a month's worth of data, we show averages of 2 hours of data for each data point. But zoom into the last hour and we can stay at 20-second bins. To override the default of average and our choice of bins, you can use the rollup function that we talked about in the previous video. With rollup, you can specify whether you want to take an average, a maximum, minimum, or sum. And also you can specify the bin size to use measured in seconds. So if you're showing the last hour and would prefer to see the minimum value every 5 minutes, you can add the rollup function with the parameters min and 300 seconds. Now if you zoom way out to show a month of data, 5-minute bins will result in about 9,000 data points, which have to get aggregated down to a more reasonable amount. So the bin choice of your rollup will be overridden, but the method you chose of minimum will continue to be observed. This aggregation is something we refer to as time aggregation. But there's also aggregation across different sources, which we refer to as space aggregation. In our example, we talked about a single host, but what about when you're collecting data on 10 hosts and want to combine them into a single line? If you display a one-day graph of 10 hosts shown as a single line, each data point represents the average of the metrics collected from all 10 hosts in a 5-minute time span. So for the data point labeled 12 o'clock, we're averaging the data points from all 10 hosts received between 12 o'clock and 12:04:59. Since each of these hosts probably reported the metric more than once in that period, we do the time aggregation first and then the space aggregation. So we average out each of the individual host values and then take the average of the values reported from all the hosts. You can change the default of average for space aggregation by clicking here in the query editor. Change average by to maximum by or minimum by or sum by. Right next to that dropdown is a text box in which you can enter any tag. If you enter region, then we show a line for each region, averaging or taking the max or min or sum, all the hosts in that region. Everything we've talked about so far assumes that the agent collects metrics every 15 to 20 seconds, without any interruption. But maybe one of your hosts has rebooted and stops collecting metrics until it comes back up. We may not collect data for some time, and for that bin of data, you may see a sharp drop that lasts only for a short time. The problem here is that we have less data to work with. To force a value to be used, we can implement the interpolation function that we talked about in the previous video. Again, interpolation isn't about filling in all missing values, but rather defining how missing values should be dealt with in a calculation with another metric. Interpolation can use the last value, or draw a line from the previously reported value to the next one, and calculate what the missing value or values should be. And those are the essential bits of information you need to know about how we aggregate data on our dashboards. If you wish to go into greater detail about aggregation, take a look at these resources. Thanks so much for watching. Goodbye.